In this video, I want to run back through numbers 2 and 3 in our hypothesis testing with Excel notes to show you an alternate way to do these one sample hypothesis tests in Excel. Now, Excel only actually has built into it the ability to do a two sample test, which we have not learned yet, but which we will learn. So we have to trick Excel into running a one sample test for us. This is a completely optional method. You may use it if you prefer it, if you like it, but it is absolutely not mandatory. The way that we ran through these before are perfectly fine. We'll get it correct every time. This is just another option if you want to check it out or want to try it this way. So the first thing I'm going to do is go back through number 2. This was a z-test, and I'm going to minimize this and look at our Excel commands document where it says z-test with data analysis. This is the option. So I've got my data in. The difference is that I have to create a dummy second sample and just put a value of 0 in there, or a couple values of 0. So I don't need those other things anymore. I'm not going to be calculating the margin of error and those different values. Instead, I'm going to create a dummy variable, and I'm just going to pop a couple zeros in there. Now I'm going to go to data and data analysis and find the z-test. And again, we really only have one sample, but we have to pick the two sample test. It's the only available option. So that's why we're being creative. So there is a z-test at the very, very bottom here that says two samples for means. So we're going to choose that. In variable 1 range, you want to put your actual data. So I'm going to put all these times in for my variable 1. And then for variable 2, we want to put in our dummy variables. So highlight however many zeros you put in there. For your hypothesized mean difference, you want to put in whatever value you were hypothesizing about. So we were saying, is this mean either equal to 40 or greater than 40? 40 is the mean that we are hypothesizing about. So I'm going to put that here. Now, for the variable 1 variance, let's look over here at our directions. Again, we have to tell it some stuff here. Okay, so it says square the given sigma value and enter that for variable 1 variance, because that's what variance is. Variance is the standard deviation squared. So we have to go back to our value here, our information. We're given that sigma was 7. That means the variance is 7 squared, or in this case is 49. So I'm going to put 49 in here. The variable 2 variance technically would be 0 because everything is zeros, but you can't enter 0 in here. Again, we're using something, a built-in function that we're using it in kind of a way it wasn't designed. So it won't allow you to type in 0, even though that's what it should be. So type in something very, very close to 0. Type in point, lots and lots of zeros, and then a 1. Okay, it shouldn't really matter as long as you get several zeros in there, 3 or 4 or 5. Click labels if you have labels. So I had labels. Make sure you enter the appropriate alpha value. It defaults to 0.05, and our alpha value in this problem indeed was 0.05, so I don't need to do anything about that. Pick an output range, so pick some blank cell over to the side to start putting this data in and hit OK. Okay, so what information do we have here? The dummy, anything in the dummy column is unnecessary. What's important is the z value, so I'm going to make that red. So notice we get a z of 2.73 approximately, and let's go back and look. Oh, the z value we calculated before was 2.727, so that's correct. But now you have to know which p-value to read off. There's a p-value for a one-tailed test, and then there's a p-value for a two-tailed test. So we have to go back up into our information and realize, okay, we were performing a one-tailed test. So we want to use this one-tailed p-value as well. And let's see, it looks like 0.003. Let's compare that to what we got before. And what we can see is, oh, the p-value we got was 0.003. Okay, so it's the same information, got a different way. It's a little bit tricky because you have to do this dummy variable, and you do have to do you have to know what to type in for the variance. You have to know that the variance is sigma squared, and then you have to type in something really small here. So we're tricking it in this way. But if you can remember those couple tricks, this is actually a faster way. It requires less by hand calculating for you, and honestly less steps. So this is an option for doing a z-test. Even if I have all of these different areas that I tell you that I want you to show me, if you choose to do it this way, just ignore this information and instead tell me the process that you used here. Remember, just a final answer still won't give you credit, but if you decide to do it an alternate way, that would be completely acceptable. Now, let's go back through number 3, the t-test version of doing this with data analysis. So I'm going to click over to the delays area. Again, we're not going to be calculating things separately, but I do have to create that dummy column again with a couple zeros in it. This time it's a t-test. So when I go into data and data analysis, the option I want to choose is the second to last one, t-test to sample assuming unequal variances. Again, for this one, we want to put our actual data in variable 1 range, and mine pre-populated in there. I actually already did this as practice, so mine is all already set up, but I'll talk you through it. For variable 2 range, you want to put in whatever you've got in your dummy column there. The hypothesized mean difference, again, is whatever you're hypothesizing about, and here we were saying it's either 300 or not 300, so 300 is the value that I want to put there. I had labels. I needed on this one to change my alpha value to 0.01, so I did that. And I clicked over to the side somewhere to put my output. So I'm going to go ahead and do that. And here is the important information I get out of that one. Again, what I need is the t-stat value. So like 1.36, let's compare that to what we had gotten. That 1.362, same value as when we calculated it by hand. And then notice this was a two-tailed test, and we got 0.189 for our p. And if we look over here, if we look at the two-tailed p, there's that 0.189, that same value. So we could explain, give the directions. This could be, I didn't scroll down. Here's that t-test with data analysis explanation for what we just did. And how you can sort of skip these middle steps again and get straight down to, well, what is the t, what is the p, and now make my final conclusion. This bottom part would be the same no matter what method you chose. So again, a secondary option that is a little bit more streamlined, but it's also, again, it's a little bit, there are some things you have to remember. You have to remember these dummy columns. You have to remember that we're sort of tricking Excel into doing this. So either way is fine with me. If you have a question on a test and an exam or a quiz, and if it's laid out for you to show all of these things, but you choose to do this method instead, you just need to explain out to the side here what you actually did. And as long as it was correct steps, even though it was a slightly different method, that would still be completely acceptable.